Hi friends, in this video we are going to tell you about electric charges. Now what is an electric charge? An electric charge is an intrinsic property of an object like the mass of a body. History of an electric charge. Some experiments have shown that there are certain pairs of materials which on rubbing could attract light objects like straw, pith balls and bits of paper. These objects are said to be electrified. Some of these pairs are amber rubbed with wool or silk, glass rod rubbed with silk and glass rod rubbed with wool repel each other, whereas the glass rod and wool attract each other. Comb rubbed with dry hair also attracts bits of paper. Conclusions from various experiments. There are two kinds of charges, positive and negative. Like charges repel each other, whereas unlike charges attract each other. Note: the property which differentiates the two kinds of charges is called polarity. The magnitude of both the charges is same, that is 1.6 into 10 raised to the power minus 19 coulombs, denoted by E. Gold leaf electroscope experiment. It is done for the detection of charge. A vertical metal rod is housed in a box and two thin gold leaves are attached to the bottom end. This is shown in picture 1. Now, when a charged object touches the metal knob at the top of the rod, charge flows onto the leaves and they diverge, as shown in picture 2 and 3. Now, the degree of divergence is an indicator of the amount of charge. Basic properties of electric charge. Now, the first property is additive nature of charges. Charges add up like real numbers, scalars. For example, we take a system of 3 charges, Q1, Q2 and Q3. Now Q net, that is the net charge of the system, is equal to Q1 plus Q2 plus Q3. Now Q1, Q2 and Q3 can be either positive or negative. The second property is conservation of charge. Total charge of an isolated system is always conserved. Taking an example, we take a system of 2 charges Q1 and Q2. They undergo some procedure and we have the final result as Q3 and Q4. According to the above law, Q1 plus Q2 is equal to Q3 plus Q4. Charge particles may be created or destroyed, but charge can never be created or destroyed. Quantization of charge. All free charges are integral multiple of a basic unit of charge denoted by E, which is the charge on an electron or proton. Now Q, that is the charge on any body, is equal to N times E, where N is any integer. But there is an exception to the quantization of charge. That is, at macroscopic level, we deal with charges that are enormous in comparison to magnitude of charge E. At this scale, the fact that charge can increase or decrease only in units of E is not possible. Therefore, we consider that charge can take continuous values at macroscopic level. Now let us talk about conductors and insulators. We differentiate between the two. Conductors are substances which allow electricity to pass through them easily, whereas insulators are substances which offer high resistance to the passage of electricity through them. Conductors have free electrons inside them, whereas most electrons inside the insulators are bound. Some examples of conductors are metals, our human bodies, and animal bodies. whereas some examples of insulators are plastics, glass, nylon, wood. Today we discussed electric charges, their history, conclusions of various experiments, gold leaf electroscope experiment, conductors and insulators, and some basic properties of electric charge. See you soon with our next lesson. Goodbye.